Hi everyone, I'm going to divide this review into different sections. This is the review for the test on graphing quadratic functions. So if we look at number one, I can see, like in my mind, I think of this as standard form. I can look at it a few different ways. I know that, this is going to be a frowny face, a quadratic, and so I'm going to go ahead and, because in my mind it's in standard form, I'm going to use negative b over 2a. Okay, so negative b over 2a is how we find the axis of symmetry. So b, see how there's no x here? So that means it's going to be 0. So I have 0 divided by, well, anything is going to get me 0, right? Normally I would say 2 times a is negative a half. 0 divided by negative 1 is going to be 0. Now, most of the time you'll just go, oh yeah, it's 0, and you won't go through all that. But, okay, so 0 squared is 0. 0 times negative a half is 0. So I know that the vertex is 0, 0. And some of you guys would have just looked at that. Okay, so now I'm going to pick two numbers smaller. Now, this is taking a half of it, so I might actually say, okay, well, it's fine, I can do 1, 2, negative 1, negative 2. Okay, so I'm going to plug 2 into the equation. 2 squared is 4, and just in case you're not sure how to do that stuff on your calculator, 2 squared is 4 times 1/2 negative is negative 2. Now, you could have probably done that in your head, we hope. Okay, plug 1 in. 1 squared is 1. 1 times negative a half is negative a half. I'd like to just confirm, but we know right now that these answers should match, right? Negative a half squared is 1. 1 times negative a half is negative a half. 2 squared is 4. Negative a half of 4 is negative 2. Okay, so when I go to graph this, I have 0, 0. Whoops, I should have done it the other way around. 1, negative a half, and then 2, negative 2. All right, I like to double check a few things. This tells me that it's a frowny face. My picture is a frowny face. I know that this is just a vertical compression, so it's gotten wider, right? A parent function would be a little skinnier, so that's gotten wider, so that's a good sign. Okay, so that is my picture. Let's look at h of x. H of x, I think of this in standard form, okay? Negative b over 2a. Notice I don't have a b, right? So at this point, I know that it's going to be 0 for the axis of symmetry. Plug in 0. 0 squared is 0. 0 times 2 is 0. Plus 1 is 1. Okay, make my x and y. 0, 1 is in the middle. Then I'm going to do 2, 1. Okay, 2. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. 1 squared is 1. Times 2 is 2. Plus 1 is 3. Negative 1 squared, 1 times 2. Okay, so now when I graph this, I'm going to double check a few things. I'm going to kind of do my graph like this. Okay, 0, 1. All right, it's a smiley face. I know that's a smiley face. I also know if I'm looking at this as a transformation, I know that this is shifted up 1. Remember, the parent function would go down to 0, 0, but because of this, I know it's going up 1, so that looks good. And it's a vertical stretch. It's a little bit skinnier than a parent function. So looking good. Okay, so now I'm going to move on to number 3. Once again, standard form. I don't love standard form, but it is what it is. Okay, negative b over 2a. So now this is my b value. So negative 8 gets me 8. 2 times a. So 8 over 4, which is 2. So 2 is my axis of symmetry. And now I'm going to plug 2 in. So 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. 8 minus 16 is negative 8. Negative 8 minus 5 is negative 13. Okay, don't love it, but what can you do? All right, so now I'm gonna plug in, okay, 2 smaller is 1, 0, 2 bigger is 3, 4. And we know that those should match up and those should match up. So I'm gonna plug 0 in. 0 squared is 0, 0, so that gets me negative 5. When I plug 4 in, I should also get negative 5, right? 4 squared times 2, that's 32. 8 times 4 minus 32 minus 5. Yep, I'm looking good. 1 squared. 1 squared. 1 squared is 1. Where am I? 1 squared is 1 times 2 is 2. Minus 8 minus 5. Minus 6 minus 5 is minus 11. Plug 3 in here. 3 squared is 9. Sometimes it's quicker to do here. 3 squared is 9. Whoop. 3 squared is 9 times 2, 18. So that's 18 minus 24 minus 5. 18 minus 24 minus 5, negative 11. Looking good. Okay, so now let's go to graph it. We notice that this is going down pretty low. So I'm going to kind of draw my x and y axis like this. 2. 1, 2, 3, 4, 5, 6, 7. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I did count wrong. But then that's 11. 1, 2, 3, 4, 5. Okay, so these are just asking for me to graph them. It's, you know, I don't really have to show the zeros. The zeros are when it goes through the x-axis. Just want to make sure that I have the vertex in there. All right, let's move on to number 4. This is in vertex form. We love vertex form. Okay, so right away I can see that the vertex, I'm looking at this number here. So the vertex is negative 1. It's the opposite to what's in there and the same as what's there. X, Y. So my vertex is negative 1, negative 4. 2 numbers smaller. 2 numbers bigger. Okay, I'm going to plug 0 in. 0 plus 1 is 1. 1 squared is 1 times 2 is 2 minus 4 negative 2. I feel like I might have done that wrong, but let's check with this one. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 4 is negative 2. 1. 1 plus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Negative 3 plus 1 is negative 2. Negative 2 squared. Okay. Looking good so far. Go over here to graph it. Oh, 1, negative 4. All right, I'm going to check a few things. I noticed that this should be shifted right 1 from the parent function. Sorry, left 1. Down 4. Oh, which, thank goodness I checked, because that just tells me of a mistake I made. See, doing that double checking, I plotted this first point wrong. Negative 1, negative 4. 1, 2, 3, 4. 0, negative 2. 1, 1, 2, 3, 4. Sorry about that. Okay, now when I double check, left 1, that looks better. Down 4, there we go, and it's skinnier than usual. Good to go. All right, 2 more, or 1 more. So this one is an intercept form. All right, so a few different ways that we can do this. If I'm gonna graph it, and I know from here that the intercepts are 2, and the intercept is -4, then I know that parabolas are symmetrical, right? So where is the smack dab in the middle? 1, 2, 3, 1, 2, 3. So this is gonna be my axis of symmetry. So I can plug in -1, right? -1 minus 1 is -3. -1 plus 4 is 3. And then I have this minus 1/2 here. So I'm multiplying these three things. So -3 times 3 is -9. Whoops. -9 times negative is going to be positive. -1/2 is 4.5. Okay, so positive 4.5. 1, 2, 3, 4.5. And sometimes it's fine if I don't need exact points, if that's all I really need, to go ahead and say, oh, whoops, something's wrong there. Goodness. 1, 2, 3, 4.5 should have been here. Sometimes we don't need all the points, we can just have those, and that kind of gives us a general picture of what it's going to be. Okay, so the other way to find the vertex, if you are in intercept form is to use the equation P plus Q over 2, and P is 2. This would be -4 over 2, which gets you -2 over 2, which gets you -1. So see, -1 was the axis of symmetry here, which we just found a different way. But then you would plug -1 in to this whole thing like we did before, and we would get 4.5. Okay? Good luck.